Patty Simpson with Simpson Math. In this video, we're going to look at the levels of measurement that our data takes on. In this series, we're looking at how to describe our variables, how to describe our data so that we know what type of math we can perform on our data. So there are 4 different levels of measurement that we're going to be looking at in this video: nominal, ordinal, interval, and ratio. And it works from the most basic math that we can do with our variables up to the most advanced math that we can do with the data that we've collected. So let's start with our nominal level of measurement. Our nominal level of measurement is going to be used or helps describe that data that is qualitative data. In other words, the data that we are collecting looks like words. It's names and labels. And with this data, the only thing we can do is count the number of data values that we have within a certain category. So for instance, hair color, gender, or your favorite pizza topping. So think about that for a second. If I asked you what color is your hair, you might answer brown or black or blonde. I can't take black and blonde and add them together. The only thing I can do is count how many students have blonde hair, or how many students have purple hair, or how many students have black hair. I'm just simply counting how many are in each category. I can't do anything else with that data that I've collected. So that qualitative data, where all I can do is simply count how many are in each category, is at this nominal or the most basic level of measurement. We move up to there to our ordinal level of measurement. Ordinal level of measurement, we're also talking about our qualitative data. That data that typically when we write it down, it is words. But it can be arranged, and it not only can it be counted like we did it back here where we count how many are in each category, but also it can be arranged in a meaningful order. We can put them in some kind of ordinal order. So you can see that ordinal, you can see that order in it. So I can put it in some sort of meaningful order. For instance, if I asked you what type of medal did you win at the Olympics, and I write down gold, silver, bronze, I'm writing down, I could count how many gold medals there were and how many silver medals there were, but I could also arrange those in a meaningful order. Gold is better than silver, is better than bronze. A lot of times we see this within Likert scales. For instance, the pain level at the doctor's. When you go to the doctor and they ask you, how much pain are you in? You might answer with a 3. But that 3 doesn't really mean a quantity. It's really a label saying I'm in a little pain. And maybe my 3 and your 3 are completely different. You know, maybe I get a little bitty hangnail and I'm like, it's a 3. And you've broken an arm and you say it's a 3. So, you know, maybe our 3s mean different things. They mean how much pain you're in. But again, if you're in the hospital for several days, the nurse could look and see, oh, look how many 3s they said. How many 5s did they say? How many 9s did they say? And so they could count the number in each category, but they could also arrange those in a meaningful order. 9 would mean more pain than 2. So if I can arrange it in a meaningful order, then it's at the ordinal level of measurement. Both of these, nominal and ordinal, are what we can do with our qualitative data. We move up from there to our interval level of measurement. With our interval level of measurement, we are now looking at our quantitative data, that data that actually counts or measures something. So this quantitative data that can be counted, in other words, I can still see how many are in each category. I can arrange them in some sort of meaningful order like I did back here. This is bigger than this is bigger than that. In addition to that, I can see meaningful differences between the numbers. In other words, I could take and I could subtract and find out this one is that much greater than this one. So I can actually look at the differences between them. However, with our interval level of measurement, there's no true zero. So when I say zero on something, it doesn't mean an absence of something. So let me give you some examples. For example, in temperature. In temperature, if I say there's a zero temperature, it doesn't mean that the temperature doesn't exist. In fact, think about the difference between our Fahrenheit scale and our Celsius scale. Zero on both of those scales means something different. But we can count the number of temperatures we have in each category. We can arrange temperature in a meaningful order. This is hotter than that. We can find differences between the numbers. You know, I can say 50 minus 30, well, the temperature was 20 greater than the day before. But that true zero is missing because zero temperature does not mean an absence of zero. That's also true with other scales that are just kind of made up, like the SAT scores. This is another example of that. If you take the SAT score and you don't, or take the SAT and you don't get a single problem right, it turns out that you don't get a zero. That's not the minimum score on the SAT. So that there's no true zero on an SAT score. And yet I can put them in a meaningful order. I can look at my SAT score and your SAT score and say yours is 100 points higher than mine. So there are meaningful differences between the two, but there's no true zero in those scores. So a lot of times our interval level of measurement, it's quantitative data or quantitative variables where the scale is kind of contrived. Last but not least, at our highest level of measurement, we have ratio level of measurement. And again, we're talking about quantitative data. In order for it to be at this ratio level, it must be a quantity. So we're collecting data that is a quantity. And it can be ordered as before. There are meaningful differences between our entries. But in addition to that, the zero indicates an actual absence of something. If I say there are 0 of them, it means there's nothing there. There's an absence of something. And because of that, multiplication can be expressed in a meaningful way. In other words, twice as many, if I have twice as many of something, it really truly means 2 times as much. Whereas like on an SAT score, just because your score doubles mine doesn't mean that you got twice as many questions right as I did. So here are some examples of that. Prices of car. If that can be ordered, you know, this is greater than that, and I can actually find differences between that. You paid $100 more than I did. We can even say your car cost twice as much as mine did. So that multiplication actually is meaningful. And the big difference there is that we can see that 0 indicates an absence. So if you didn't pay anything for it, then there was an absence of an exchange of money. Or maybe there was just an absence of a purchase. Time is another example of that. If there's 0 seconds that happened, you know, how much time did it take you to run the race? 0 seconds. Well, then you didn't run the race. Ages, if you're, you know, not even born yet, then you've got a 0. There's an absence of age there. And height, if there's no height, then there's an absence of something. So, and in addition to that, all of those things can be arranged in a meaningful order. There are meaningful differences, and you can actually see multiples of those. With those levels of measurement, then we can begin to do some different math, and we can determine which type of statistic can I find for each of my data that I've collected. So for instance, if I've collected hair color, there are certain things I can't find. I can't find a mean average of hair color. I can't take your blonde and your brown and your black and add those together and divide. That doesn't make sense. The only thing I can do statistically is I can find maybe a proportion of my population that has black hair. Or I can find a percent of the population that has purple hair. So this hair color and gender and favorite pizza toppings, those at the nominal level, I can't find a mean for those things. So being able to tell the level of measurement helps me to determine which type of statistic I can actually find. But with prices of cars, I can find the mean. I can actually do some addition and division. And especially since there's that true zero involved in that, I can find mean averages. I can find all kinds of different statistics. We'll learn about those as we go along. But the level of measurement lets me know which types of statistics I can find for the data that I've collected. Math Made Simple at Simpson Math. Thanks for watching.